Okay, I apologize again. This computer just doesn't want to work tonight, and again, you'll just have it in 4 pieces. Hopefully not more than that. It keeps going out on me. We'll see how it goes, because I don't have the software here to put it back together. So again, to specify how wide and how big it's going to be, you would put in a number and just find a point to kind of see how the curve goes. So here, notice that x cannot be smaller than 3. It could be 3, but we're not going to do that. That would be 0. So let's say x is 5. So if we put in a 5 there, what will we get for, let's put in a 7 there, okay? And we'll find out what we get. So we're going to try, if x equals 7, then what will y equal? That'll be 7 minus 3, which is 4. Square root of 4 is 2. 2 times 2 is 4. And 4 plus 4 is 8. So when x equals 7, somewhere out here, then y needs to be equal to, ooh, hey, I didn't do too bad. Y needs to be equal to 8, somewhere around about in here. Okay? So all it takes is 1 point to know how stretched or how shrunk it's going to be. So if you're having to draw it by hand, go ahead and put out 1 point so you'll know how big to make it. Remember, that's kind of how we did it on the parabolas. You're mainly going to be using a graphing calculator when you do this stuff. And so you just need to know what you're doing. Remember, you got to be as smart as a calculator, or you can't use a calculator. Okay. A few of these. Let's look right here. Okay. How will that compare to the graph of y equals x squared? Square root of x, I'm sorry, y equals the square root of x. What will it be? It will be stretched up. Okay? This one, 3/2. That's a fraction, but it's bigger than 1. So this will be stretched, but not all that much. Here, y equals negative 0.8 times the square root of x. Well, that's just a fraction in disguise. That's a decimal. Okay, so that's it. Whether it's a fraction or a decimal, it's between 0 and 1 absolute value. So that's all that really matters. Okay? So it will be shrunk, it'll be squished down, and notice that the negative is on the outside of the radical sign, so it's perfectly permissible. That just means it's reflected over the x-axis, so it'll be like a reflection in a mirror. Some of these down here, y equals the square root of x plus 1. That will be the same shape as the parent function, but it will be shifted. This is k. This is the y-intercept. It's going to shift up 1 unit. Here, we have x, the square root of x minus 4. Okay, well, same deal. It's still square root of x, and then k is changed. So this will slide down the y-axis 4 units, and that's where it'll start. So the starting point, I didn't say it, but I think it's obvious by this point in the course. That's the same thing as saying x minus 0 or x plus 0 there. So this other, the x value of the beginning point will be 0 because there's nothing there, because we have a number for nothing, and the number we have for nothing is 0. So here, from our form, remember we had h and k. So in this example, the h is 0 because it's not there, because the number for not there or for 0 is, is 0, and it's just not there. So our h and our k, remember that the one inside is like that funky point slope form, and the form has a minus, and so you have to switch it to the other. And then the y value is the one that's out there all on its lonesome. So these are out on their lonesome. They shift the y-intercept. Notice that these are inside the radical. That is the h value. So here it's going to be the x value 1. And what's k? It's not there. What is it? Oh, it's not there. We have a number for not there. It's 0. Okay. So this is the beginning point is at 1, 0, and it's the usual shape. Here the beginning point is at negative 4, 0, and it's the usual standard shape. When we do both of them, for example, right here, oh, that one's not both of them. That one's both of them. No? Do I have a both of them? Well, when we have a both of them, then you do it both of them. And here endeth the lesson, the fourth part of the lesson. What a pain. Okay.